All right, we're on part 2 of the factor theorem. Let's read the directions. Part 2, the factor theorem, finding the zeros and then writing the factors of the functions. So it says at site 3, don't worry about a website. I printed it out. Here we are. Read the information on the factor theorem. The factor theorem indicates that if you can find the linear factors, x minus r, of a polynomial function, then you can find the zeros of the function. In part 1, that's the one we just got finished doing, you found the factors and used them to find the solutions, which are the zeros of the polynomial function. This is going to be a quick way to scan the many ways the factor theorem can be used. The factor theorem also states that if you know the zeros of the polynomial, you can write the factors. So that's what we got going on here. So now we have a new function that we're taking a look at. And first thing we need to do is graph this function. So you're going to want to use Desmos probably. You want to type this in and graph it. And it says use a graphing calculator. Identify at least 2 zeros that are integers. Now, I've already graphed this, so I'm going to trust that you know how to type this into Desmos. Look at your graph. You're looking for where it crosses the x-axis. When I graphed this, I found a whole bunch of different spots that it crosses, but I'm looking for an integer. So no decimals, no fractions. I'm looking for like 1, 2, 3, 4, 5, or -1, -2, -3, -4. So I'm looking for an integer. So when I graphed this, I saw that it crossed at -2, 0. I saw that it crossed at -1, 0. And I also saw that it crossed at 2, 0. Now, there was one more solution where it crossed, but that was not an integer. So we are looking for 4 answers because my highest exponent is 4. 3 of them we found from the graph, which is fantastic, but that last one was not an integer, so I'm not going to use that. Now, if I put this in factored form, like I briefly talked about in the other video, if I put this -2, 0 in factored form, it's going to be x plus 2. If I put this in factored form, it's going to be x plus 1. And if I put this in factored form, it's going to be x minus 2. So that's all there is to number 1. We graphed it using Desmos or your own little graphing calculator. Identify at least 2 zeros that are integers. I listed out all 3 of them, but we only had to identify at least 2. All right, step number 2. Step number 2. Use synthetic division and the 2 integer zeros from problem 1 to reduce the polynomial so it can be factored. And we're going to follow these steps. Divide the polynomial by the first integer, divide by the second one, and then write my row as a quadratic equation. So we're going to take 2 of these, do synthetic division twice so that we can break it down. So no particular reason. I'm going to use probably just the first 2. Again, no particular reason, but I'm going to use this one and this one. No reason, they're just first 2 I wrote down. So this is x plus 2. So in factored form, if I'm dividing, -2 goes in the box, which is what we also got from the calculator. So -2 goes in the box, and I'm going to do synthetic division. So 3, 8, -7, -32, -20. First number always comes down. And we're going to do synthetic division. So multiply, add, multiply, add. This comes down, gives me -6. Add, multiply, gives me -4. Add, multiply, that's 22. Add, and -10 is 20, and 0. At this step, you should get 0. I know I should get zeros because the reasons I know I should get 0 is because I got this from the calculator. We graphed it and I saw it crossed at -2. So -2 is an answer. It has no remainder. We graphed it. We saw it crossed at -1. -1 is a solution. So it works out perfectly. There's no remainder. If you decided to use this one down here, you still should have got 0 as your remainder. Now, if I write my answer out, we started x to the 4th. So my answer should start x to the 3rd. So now I'm at 3x to the 3rd plus 2x squared minus 11x minus 10. Now the directions say don't start over. So now divide the solution row by the next integer you found in problem 1. So do not start over. And it says again, notice the remainder is 0. So now I'm going to use my second number. We just used -2. Now I'm going to use -1, and my remainder should be 0. So -1 goes in. I use this. Don't start over. I'm using this. So I got 3, 2, -11, -10. First number comes down. First number comes down. I'm going to multiply, add. So this gives me 3 times -1. I got -3. Add. -1 times -1 is 1. Add. -10 times -1 is 10. Add. Again, we should get 0. I'm going to write this answer out. X to the third is where we started from, so my answer should start x squared. So my answer is now 3x squared minus x minus 10. So let's make sure we did everything we were supposed to. Divide the polynomial by the first integer, check. Divide the solution row by the next integer, and we should get 0, check. And then the last one says, write the resulting row as a quadratic. Now my resulting row is a quadratic. So we are good to go for number 2. All right, number 3. The factor theorem states that if r is a 0 of the polynomial, then x minus r is a factor. So that is what I was saying as far as if it crosses at -2 in factored form is x plus 2. If it crosses at -1 in factored form is x plus 1. Write the two solutions from problem 1 as linear factors. So that means we need to factor 3x squared minus x minus 10. So let me rewrite that down here. Okay. So we are going to factor 3x squared minus x minus 10. So this is the second time today because we had to do it in the first video. We're going to have to go through and do the 4-step method. Step 1, multiply the first and the last number. X squared minus x minus 30. Step 2, factor like normal. Normal is the 2 sets of parentheses. You put in your x's. We're trying to think of 2 numbers that multiply to give me -30, add to give me -1. That's -6 plus 5. Step 3, divide by the first number in the problem. In this case, my first number is 3. So I'm going to divide by 3, divide by 3. So now, 6 divided by 3 is 2. And this gives me 5/3. And the last step, you cannot have a fraction in factored form. So I need to multiply just this part by 3. So this gives me x minus 2. 3 times x is 3x. 3 times 5/3 is 5. So now I have my 2 factors. So that is what number 3 told us to do. All right, number 4. You now have 2 factors of the polynomial. Factor the resulting quadratic from the synthetic division in problem 2. Write the complete factorization. So technically, we've already factored it. We did that up here. 3x squared minus x minus 10 factors into x minus 2 times 3x plus 5. Write the complete factorization of this. And hint, you should have 4 factors. So we need to list out all 4 factors that we've gotten from this problem. So let's see what we got. I know that I got 2 up here. That was 1, and then this was 1. So let's write those down. X minus 2 times 3x plus 5. Now, where can we find the other 4? Well, let's go look and see what we were doing up here at the beginning. So we've used x minus 2, and we got 3x plus 5. Earlier, I listed out all the solutions that I got from the calculator. And let me bring in a little closer for you. So x plus 2 we got from the calculator because it crossed at -2. X plus 1 was the solution because we got it from the calculator. And then x minus 2 we got from the calculator. So our 4 factors, we've already used x minus 2 and then 3x plus 5 from the factoring. So these 2 are my other factors. The 2 that we did synthetic division on are our other factors. So that would be x plus 2 and x plus 1. So one more time in case we missed that. These 2 factors we just got from factoring this quadratic. These 2 factors are what we used when we did synthetic division. So now we have all 4 factors, because right here it said we should have 4 factors. Last up, number 5, you can now find all the zeros by setting each factor equal to 0 and solving. What are the results? So I set each of these equal to 0 to get my 4 solutions. X minus 2 equals 0. 3x plus 5 equals 0. X plus 2 equals 0. And x plus 1 equals 0. These are all one-step equations except for the 3x plus 5, but they're not bad. You can easily solve. Add 2 to both sides. I get 2. Subtract 5, divide by 3. Subtract 2 from both sides. And subtract 1 from both sides. So we have our 4 solutions. So what else can we get from this? Just as we talked about in part 1, first of all, notice it breaks our polynomial down. Way up here at the top, we started with something that was x to the 4th power. We broke it down to something more manageable using synthetic division, and it broke it down into x squared. So we started with x to the 4th, it broke it down to x to the 3rd. We did synthetic division again, it broke it down to x squared. Then we factored and it broke it down into things that were x to the 1st power. So the factor theorem is helping us break stuff down. It's also giving us ordered pairs. So this here is telling me that 2, 0 is an ordered pair. It crosses the x-axis at 2. This is a solution, a root, a 0. This one is negative 5/3, 0. The next one is negative 2, 0. And then the last one is negative 1, 0. So it's giving us ordered pairs. It's breaking the polynomial down. It's helping us factor. So the factor theorem is giving us lots of useful information that we can do with our polynomial.